Hello everyone. In this video, on behalf of my team members, I would like to present an experiment in analog and digital circuits. The presentation is about determination of bandwidth of single stage and multi-stage amplifiers. The objective of the presentation is to understand the concept of single stage and multi-stage amplifiers, to simulate using Multisim software, to calculate the gain and bandwidth. Finally, to compare the results in terms of gain and bandwidth. Before simulating using Multisim software, we will have some basic ideas about the concept. What is an amplifier? An amplifier is an electronic device or circuit which is used to increase the magnitude of the signal applied to its input. Next, based on the number of transistors or number of stages used in the amplifier, it has been divided into two. One is single stage amplifier and another is multi-stage amplifier. Single stage amplifier, when in an amplifier circuit, only one transistor is used for amplifying a weak signal. The circuit is known as single stage amplifier. Whereas in multi-stage amplifiers, we can use n number of transistors. The main purpose of the multi-stage amplifier is increased gain. Also, in multi-stage amplifier, the output of the first stage is coupled using a coupling device, that is capacitor, to the input of next stage. This process of joining the two amplifier stages is called as cascading. Also, the increase in overall gain causes the reduced bandwidth. Next, the gain of the multi-stage amplifier. The overall gain of the multi-stage amplifier is the product of the gains of individual stages ignoring the potential loading effects. Alternatively, if the gain of each amplifier stage is expressed in decibels dB, the total gain is the sum of gains of individual stages. The complication in calculating the gain of cascaded stages is the non-ideal coupling between the stages due to loading, because the input resistance of the second stage forms a voltage divider with the output of the first stage. So, the total gain is not equal to the product of individual gains. That is, the overall gain is less than product of individual stages. Next, moving on to the bandwidth. The bandwidth of multi-stage is less than the bandwidth of single stage on observing this frequency response. In multi-stage amplifier, my lower cutoff frequency is always greater than the lower cutoff frequency of single stage, whereas the higher cutoff frequency of multi-stage is always less than the higher cutoff frequency of single stage. So from this, it is clear that the bandwidth of multi-stage is always less than the single stage. Now we are going to simulate the same concept in Multisim software, and we will compare the results in terms of gain and bandwidth, and we can, at the end of this video, we will have a conclusion about the gain and bandwidth of single stage and multi-stage. This is the circuit which I'm going to use to design the single stage amplifier, which consists of only one transistor, voltage divided bias technique. And for multi-stage, I have used only two transistors with similar stages. My first stage is similar to my second stage. I have coupled this using a coupling capacitor. And we will tabulate the results. We will use the Multisim software. This is the work area of Multisim software. We can place the components from this last row. Like, this is my place sources. From sources, we can take, from power sources, we can take ground and plus VCC. If I need ground, just click OK. Ground has been placed. For VCC, place OK. CC has been placed. Then signal voltage sources. From this, I will take AC voltage for my input. And next, we will exit from the screen and go for play basic, from where we can get resistors and capacitors. For voltage divider bias, I need 4 resistors. I will place 4 resistors. And next, I will select capacitors. I need 2 capacitors, one for my input coupling and another one for my output coupling. Finally, I need 1 transistor. I select BJT NPN transistor. In BJT NPN, I select BC547BG. Okay. Exit this screen. Once I have placed all the components, I'm going to edit this. Just double click on this edit model. I will edit the value of beta 1 to 150. Enter. Change this. Also, we can connect this using the wires like this. Okay. So this is how we can design circuit using multisim. I've already designed for a single stage. This is my single stage. Just go for simulate. This is ready to simulate. Go for analysis and simulation. AC speed, output. It is, as we know, the gain is the ratio of output voltage to input. My voltage gain is output voltage divided by input voltage. Here, my output is V5 divided by input V8, voltage at node 8. So V5 divided by V8, I will redo this, remove this expression, add it. It is V5 divided by V8. V5 divided by V8. Okay. Now run this. You can take cursors from here. Here. You can take cursors from here. Place my first cursor in the mid frequency. I could observe for cursor 1, Y1. Y1 shows the gain. So it is obvious that the gain of my single stage is 3.73. Now we will note this here. This 3.73. Okay. Now we will calculate for bandwidth. My bandwidth is calculated at 3 dB gain. For calculating the 3 dB gain, I will take 3.73, my mid gain, into 0.707. 0.707 is nothing but 1 by root 2. It is 2.63. Place both the cursors at 2.63. Okay, 2.63. From this, we can see the bandwidth. Bandwidth is nothing but the value at dx. So the bandwidth is 73.99 megahertz. That is approximately equal to 74 megahertz. 74 megahertz. 74 megahertz. Okay. Now we will calculate for multi-stage amplifier. This is all about single stage. Next, multi-stage amplifier. Okay. For multi-stage amplifier, my output is at V9, input is V8. So V9 divided by V8 will be my expression. Go for AC sweep. Here it is V9 divided by V8. So we can simulate directly, run this. Take cursors, place on the mid frequency. Now observe Y1, it is 9.98. My multi-stage gain is 9.98. We'll just make a note here. .98. Okay. Next, we will calculate for bandwidth. 9.98 into 9.98 into 0.707, which is equal to 7.05. Place both the cursors at 7.05. Approximately it is 7. Here, as in single stage, we have observed in multi-stage the bandwidth is at dx. The dx is 10.93 megahertz. 10.93 megahertz. .93 megahertz. Okay, fine. Now it has been cleared from this tabulation. The multi-stage gain has been increased, whereas bandwidth has been reduced. 74 from 74 megahertz to 10.93 megahertz. There is a drop in bandwidth, but there is a increased gain. We also calculate the loading effect. For this, we will do some alternations in this AC sweep. Go for AC sweep. Here, we could see my gain of my second stage alone is V9 divided by V2. That is, here this output has been fetched to the input. So V9 divided by V2 is the gain of my second stage, whereas V2 divided by V8 is the gain of my first stage. Output, I'm going to add expression V9 divided by V2. V9 divided by V2. Okay, and one more expression V2 divided by V8. V2 divided by V8. Okay, now we will simulate all these three expressions. Run. We can see three waveforms. Here, my red color is multi-stage. Blue is V9 divided by V2. That is my second stage. V2 divided by V8 is my first stage. Here, I will place my first cursor at the mid frequency. So, if you observe carefully, you can see this Y1 alone you observe. At Y1, my total gain is 9.98, which is we get from the previous simulation. And 3.73 is my single stage. But V2 divided by V8 is decreased 2.67. That is, actually, I've used similar designs for my first stage and second stage, but the gain of my first stage has been reduced, whereas my second stage remains the same as in for single stage. So from this, I would like to tell you the second stage acts as a load to my first stage. So on adding a load, the gain decreases. So what? The gain of my first stage alone get decreased when we compare both first stage and second stage. But the second stage is not connected to any of the external load. So the gain of my second stage remains the same, that is 3.73. So this is what the effects of loading. So the first stage gain has been reduced. So on, if you increase the number of stages, if you put third stage, if you include third stage, my gain of my second stage also get reduced, whereas my gain of my third stage will remain the same as 3.73. Now we will look to the acceleration. As we seen, the single stage amplifiers gain and bandwidth, multi-stage amplifiers gain and bandwidth. Now, the product of gains of individual stages is 3.73. Single stage, as I have used a similar circuit for stage 2, I just multiplied the same gain twice. It gives 13.91. But here we can see 13.91 is not equal to my multi-stage gain, that is 9.98. As I stated before, my multi-stage gain is always less than the product of individual gains. So hence it has been proved here. Finally, the conclusion of this video is the gain of the multi-stage amplifier is less than the product of individual gains of all stages due to loading effect. And the gain of the multi-stage amplifier increases with reduced bandwidth than that of single-stage amplifier. Thank you.